Hey everybody, so in this video we're going to finish talking about section 7.3 by talking about solving exponential equations. So we're actually going to talk about two different methods to solve exponential equations. The first method is a little bit more straightforward, but it doesn't always work. The second method is a little bit more complicated or more confusing, but it does always work. Okay, so let's talk about the first method. Okay, which is called equating exponents. Okay, so the first step we're going to do is isolate the exponential. Okay, so remember the exponential part is the part that looks like b to the x power, where b is a number and x is our variable. Okay, then the second thing we're going to do is try to write everything in terms of the same base. Okay. So it might be the base b that you see in the equation. It might be a different base, but you're going to write everything in the equation as a power of that same base. Okay. Then we're going to simplify. Okay. Now this is only if that's possible. Okay. Then we're going to equate exponents. Okay, so this step is obviously the step that gives the method its name. Okay, so equate obviously meaning that they're equal to one another. Okay, so you'll see how we do that. Okay, and then the last one is to finish solving. Okay, so let's see some examples of using this method. Okay. All right. Okay, so our first equation is going to look like this, okay? Now we can see that the exponential part, which is this part, is already isolated, okay? It's not multiplied by anything. We don't have any addition out here, so this term is already isolated. So we're done with the first step, okay? So now we're going to try to write everything in terms of the same base, okay? So we can see here that the base is 3, and here we have 27, which is a power of 3. Okay, so what we're going to do is leave this as a power of 3. Okay, and we're going to rewrite 27 as a power of 3. So we'll rewrite it as 3 cubed. Okay. Now would come the time where we would simplify this if that was something we needed to do. Okay, we don't need to simplify this. It's already simplified. So here's the step that we're calling equating exponents, okay? We can see that these two equations have the same base, that they're equal to one another, okay? So this means that the exponents must be equal to one another, okay? So this is what we call equating the exponents, when if these two expressions are the same, then the exponents must be the same, okay? And now we can finish solving by adding 1 to both sides. Okay? So this is really what equating exponents is all about. Let's see another example of this. Oops, I can't see that. Okay. So the first thing we're going to do is try to isolate the exponential, okay? And again, in this equation, this is already isolated, okay? Now we're going to write everything in terms of the same base. So we look here, we have the base 2, and then we have 16, which is a power of 2. So we're going to write everything as a power of 2, okay? So we have 2 to the 2x minus 1, okay? And then we're going to write 16 as 2 to the 4th. Okay, so this would be 2 to the 4th, okay, because that's the same as 16 to the 1/5 power. Okay, so here's an example of when we can actually simplify this. We're going to use our exponent rules to simplify this by multiplying these two exponents. Okay. All right, so now we can see that we have two expressions that are equal. They have the same base, so we're going to equate the exponents. Okay, and then we can finish solving this normal linear equation. Add 1 to both sides, okay, and divide both sides by 2. Okay. All right. Let's look at a few more examples of this. Okay. So we're going to try to do the same thing here, okay? So again, we can see that the exponential is already isolated, okay? So this side is fine. We don't need to do anything. And then we're going to look at everything and see what number we might want to use as our common base, okay? So here we have 2, okay? Here we have root 2, which we know is obviously related to 2. And here we have 16, which is related to 2. So we're going to use 2 as our common base. So this is already written as a power of 2, okay? Now, the square root of 2 we know is the same as 2 to the 1/2 power, okay? And 16 we know is 2 to the 4th power. Okay, so we're just writing everything we see as a power of 2. Okay, then we're going to simplify, and we know that when we have a fraction, we subtract the exponents. Okay, so we have 1/2 minus 4, which is -7/2. Okay. Now we have two expressions that are equal. They have the same base, so we can equate the exponents. So 3x minus 1 must be equal to -7/2. Okay, and now we can solve this normal linear equation. Add 1 to both sides and divide both sides by 3. Okay, and there would be my final answer. All right, let's look at one more example like this. And then we'll look at our second method for solving these types of equations. Okay. So this one actually has two exponentials, but they're each isolated, which is fine. Okay. So now we're going to try and look at what base we might be able to use here. Okay. So we have the base 27. Okay. If you think about the factors of 27, we could use 9 as a base, or we could use 3 as a base. okay? Then we look at 81. Again, we could use 9 or 3. I think it's easier to choose the smaller of the two, 3, just because we know how to write 27 as a power of 3. It's going to be hard to write 27 as a power of 9. Okay, so we're going to go ahead and pick 3 because both 27 and 81 are powers of 3. Okay, so I'm going to write 27 as 3 cubed. Okay, and I'm going to write 81 as 3 to the 4th. Okay, and now I'm going to simplify these by multiplying these exponents. So I get 3 to the 12x plus 6, okay, equals 3 to the 4x minus 4. Okay, now my expressions are equal, they have the same base, so I'm able to say that their exponents must be equal. Okay, I wanted to point out that we can't start by equating the exponents because these two expressions don't have the same base. Okay, we don't know that 2 to the x and 3 to the y have the same exponent x and y because their bases are different. Okay, all right, so now we can go ahead and solve this. So we'll subtract 4x from both sides, subtract 6 from both sides, and divide both sides by 8. Okay, and this would be my final answer. Okay, so this is really what equating exponents is all about. The only part that can be tricky is trying to pick the right base. Usually if you look at what these bases are both powers of, that will give you a clue, okay? And then you just need to write them as a power of that base. All right, so let's look at our other method to solve. Okay. Okay. And this is going to be using logarithms. Okay. So in lots of cases, it's not possible to write both sides of the equation as powers of a single base, okay? And that's when we'll be in the case that we need to use this method, okay? So the first step is the same. We are still going to isolate the exponential. Okay? And then we're actually going to change to log form. Okay? We're going to simplify. And then we're going to solve normally. I guess finish solving normally. Okay. All right, so let's look at some examples of using this method. Okay. Okay, so the first thing we're going to do is isolate our exponential. So here's our exponential, and we're going to isolate this by dividing both sides by 5. Okay. Now that we have our exponential isolated, we're going to change to log form, okay? So the base of the log is the base of the exponent, so we're going to have log base 5 of 25 equals 2x, okay? Now we have to simplify, and we're going to evaluate this log here. So log base 5 of 25 is 2. Okay, remember we're asking what power of 5 is equal to 25. Okay, and then we can finish solving this equation by dividing both sides by 2. Okay, all right. Now, I do want to point out that we certainly could have done this example using the equating exponents method, okay, but you can also do it using this method. Let's look at another example. Okay. So again, the first thing that we're going to do is isolate the exponential, which is the 4 to the x part, and we're going to do that by dividing both sides by 90. Okay. Now that we have our exponential isolated, we're going to change to log form. So we'll have log base 4 of 2 equals x. Okay. Now the only thing we have left to do is to evaluate log base 4 of 2. Okay. So we're asking what power of 4 is equal to 2. Okay. Well, we know that the square root of 4 is equal to 2. Okay, which is the 1/2 power. So log base 4 of 2 is going to be 1/2. Hey, buddy. Okay, so here's my solution for this equation. Okay, again, I could have done this problem using the equating exponents method, but here's how you can do it using the logarithms method. Okay. So let's look at an example of something that we absolutely could not do using the equating exponents method. Okay. Good. Okay. Hang on, we're gonna have to have a little pause here. Okay, so we have this equation and we want to solve it using logarithms. Okay, so we're gonna try to isolate our exponential, which is this part, the 10 to the 1.4x. Okay, so the first thing I'm gonna do is add 11.6 to both sides to get rid of this. Okay, so this is gonna be 23.8. Okay, and now I want to go ahead and divide both sides by 2. Okay, so we're going to divide both sides by 2. Okay, so we're going to take 23.8 and divide it by 2, and that gives us 11.9. Okay, this will be 11.9 equals 10 to the 1.4x. Okay, so now that we have our exponential isolated, we can go ahead and change to log form. Okay, so remember that the base of the exponent becomes the base of the log. Okay, here's my input, and my answer is 1.4x. Okay, now 11.9 is obviously not an even power of 10, so we can't evaluate this logarithm by hand. So we're actually just going to leave our answer exactly like this. And our last step to solve is just to divide both sides by 1.4. Okay. All right. So remember, if you have log base 10, you don't need to write it. It's the common log. Okay. So this is my exact answer. Okay. And if I wanted an approximate answer, I could certainly plug this into my calculator. Okay. So I would, again, you're using the common log button, which just says log. Okay. So I'll have log of 11.9. Okay. Divided by 1.4. Okay, and that gives me my approximate answer, 0.768 or 0.77. Okay. All right. Now, it's important to remember that you guys aren't going to have calculators for the quizzes or the exams. Okay, so you're going to be giving an exact answer like this. All right, let's look at one more example like this. Okay. So what we're going to do here is first we're going to get rid of this 80 by dividing both sides by 80. Okay. So we're going to go ahead and do that. Okay. Okay. Now you can see that both 65 and 80 are obviously divisible by 5. So we're going to go ahead and simplify my fraction here. Okay. All right. Now I want to point out again that for some reason people are tempted to subtract these numbers, even though these are definitely unlike terms. Okay, so don't be tempted to subtract these. You can't subtract them. They're unlike terms. Okay, there's no way to subtract something that has a variable exponent from just a numerical value. Okay, so I'm going to go ahead and subtract 1 from both sides. Okay, and then I'm going to divide both sides by -1 to get rid of this. Okay, now that I have my exponential isolated, I'm going to go ahead and change to log form. Okay, so again, the base of my exponent becomes the base of my logarithm, so I'm going to be looking at the common log base 10 of 3 over 16 equals minus 0.2x. Okay, again, it's obvious that this number isn't going to be an even power of 10, so we're not going to try to evaluate this if we can't do it by hand, and we're just going to divide both sides by -0.2. Okay. All right. So this is my exact answer. And if I want my approximate answer, then I'm going to go ahead and plug this into a calculator. Okay, so I would have negative log of 3 divided by 16 divided by 0.2. Okay, and this is going to give me 3.63. Okay, and that's my approximate answer. All right. So one last thing that I wanted to say is when you're doing these ones that don't come out evenly like this is when you're really forced to use this method versus the method where you're equating exponents. Okay, I also want to caution you on the homework against evaluating this with a calculator and then dividing both sides by -0.2, because remember on the quizzes and the tests you won't have that option. So it's best to practice giving an exact answer and then plugging everything into the calculator at once. Okay. I hope both of those methods make sense to you, and I will see you guys soon.